LeetCode 242, valid anagram in JavaScript. Given two strings, s and t, return true if t is an anagram of s, false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. This is more garbage, imprecise wording from LeetCode. We care about strings as programmers, so what they want to know is, given two strings, s and t, for each character in s, it must occur exactly the same number of times in t, and vice versa. So if there are 3 a's in s, there must be exactly 3 in t. For each character in s, it must occur exactly the same number of times in t, and vice versa. Our first check can be to make sure that they're of the same length. If they're not of the same length, then obviously they are not anagrams of one another. And this is mutually conditional, right? If s is not an anagram of t, then t is not an anagram of s. If s is an anagram of t, then t is an anagram of s. So it's biconditional, right? They're either both anagrams of one another, or they're neither one of them are anagrams of one another. Okay. The way that I've implemented this is to create a map of the characters in T. We don't need to know the order that they occur in, but we do need to know the number of occurrences. So for 3 A's in T, we need to know that there are 3 A's in T. So we're going to create a map. We're going to accumulate each A, and we're going to tally them up. And then we're going to iterate through S, and we're going to take them off the tally. So we're going to subtract an A, we're going to subtract an A, we're going to subtract an A. And if we get through all of the characters in S, and we've subtracted every character, and it also occurred in T, we could subtract a character, it was present in T, and we could subtract it, then we're done. So, as I said before, the first thing we do, well, we have a use strict. That's just out of good habit. We check to see if they are not the same length. And if they're not, then we return false. And we create our map, and then we have an iteration, through an enumerable T. Strings are enumerable, just like arrays, and even node lists, DOM node lists in JavaScript are enumerable. It's a nice thing to have. Node list is not part of ECMAScript language, it's part of the DOM, but it's nice that there is that communication between the two working groups, and that we have that enumerability of node lists. Nice little aside. So in this for of loop, which is more concise than a for loop, we assign each property to T. So given the n property of our first k is n, tmap n is going to be equal to, first we're going to look at this grouped expression, tmap n, we have to look at it again, is undefined. So in Boolean context, undefined is false. So then we're going to take 0. Okay, and then we're going to add 1 to the result of that. And then we're going to assign the result of 0 plus 1 to tmap. So the first time we get n, tmap n is going to be equal to 1. Right, and so when we get to this a, well, then that's going to be 1, and then g is going to be 1, and then a, tmap a is going to be equal to, tmap a is 1, and we're not going to take this 0, but we're going to add 1 to 1, and that's 2. So in the second A, it's going to, after that, it's going to be 2. So that's how that loop works. In the second loop, we loop through S, and we use the same name for the character. It doesn't even matter because it's just a different loop, different scope, different variable activation object is in both. Okay, now we need to check here to see if that character in S. So when we loop through S, we check A first. Does A exist in tmap? Why, yes, it does. So if it's not, however, if we didn't have that character in tmap, we would instantly return false from that function. Return false as soon as possible. That makes things faster. Okay, so if we've made it past this statement without returning false, we can make past the statement, then we check tmap, we minus using the pre-decrement operator, and we get the property value of the property name, let's say A in this case. Now let's say A were 2. Let's say well, to begin with it's 3, but after we've created the tmap it's 3, and then we've gone through once, and then it goes down to 2, and then it goes, so now it's at 2, and now we get the second A in S. We're here. through S. We've gone through A, we've gone through N, we've gone through A. Now we're getting through A again. So T map A is 2. 2 minus 1 is 1. So that's still going to be 1. So we still have 1 after evaluating this expression. In Boolean context, 1 is true. Any non-zero number in Boolean context is true. So 1 in Boolean context is true. That means we're not going to evaluate the right-hand side of this logical OR operator. We're going to short circuit when that's going to be true, and we're going to continue on our loop. However, in the next iteration, when T map is 1 and we have another A, and T map A is 1, okay, so now we get the value of that. It's 1. We reduce that. We pre-decrement it by 1, and the result of evaluating this expression is now 0. And in that case, in Boolean context, 0 is false, and we delete it from T map. Therefore, in the next iteration, if we were to, hypothetically speaking, get to another A in S, is in both K and T map. Well, we know that K, if K is in T map, that it would be that we would continue on. So K is in T map, A would be false in that because we already deleted it from T map. So is in both is going to be false. So that way we would quickly return false. And finally, since we've already enumerated through everything in S and we removed all the characters in S and they were the same length, we can just return true from this function. Now it initially occurred to me that we might want to check the keys.length of tmap to make sure that we had no more keys in tmap. But that isn't even possible at this point because we've already deleted them while we were enumerating through S. So we've already deleted them all. And if there were any more, well, that would have already been checked in the beginning because we have the same number. So we have the same number and the same number of occurrences in both. And that's how this works. Thanks for watching, everybody.